Alright, so we're going to be solving rational equations, and what that's going to require us to do is make sure, before I start trying to solve this equation, is making sure that all of the denominators are the same. And then when you look at these, you can tell that one of them is missing something. The one in the middle here does not have a b. It does not look like the rest of these, and the way we're going to fix that is by multiplying by whatever we need to multiply by to make these the same. So I would need to multiply this one by b to make it 2b. But with fractions, if I do something to the bottom, I'm going to also do the same thing to the top. And once I have done that, I've made all those denominators the same. I can essentially just ignore what's down here and look at just the top of this. Just look at the numerators now, and I'm going to write those down here. I've got 3b plus 9 equals, and then 1 times b is just b, plus all that was being added to b minus 3. So what I do is, once you have made all of the denominators the same, kind of just look at what's left in the numerator. What operations, what terms are up there. So we had 3b plus 9 equals 1b plus b minus 3. Okay, and I'm going to now just treat that like it's an equation. And now I basically am going back to solving equations like we did in Algebra 1, where I want to combine like terms if there are any. And here I have a b plus b. I can add those. Those are like terms. And when you add b plus b, you get 2b. Alright, so I've got 2b minus 3. And then I've got on this side 3b plus 9. And once we get to here, it's a matter of getting my variable to one side of the equation. That's going to be kind of the next thing that I want to look to try and do. So I'm going to get my variable to one side of the equation, and the easy way to do that is to look at the smaller one, like 2b. I can subtract it and still keep things positive. So now 3b minus 2b is just b, or 1b. Everything else I'll bring down. I cancel this out. So now I've got b plus 9 equals negative 3, and to continue or finish solving this, I would just subtract 9 from both sides, and then my final answer is going to be b, because this cancels out, equals negative 3 minus 9 is negative 12. That would be my solution to this equation. Okay, so that's how a very basic question would look, or an equation would look if I'm making I have to make these denominators match before I can do anything. But once they match, just look at your numerator now, and it now becomes an equation, and you would just solve it for whatever the variable is that we're trying to solve for here. And we'll also see questions like this where none of the denominators are the same. And the easy thing to do is look at the biggest denominator. I've got 4n, that's the biggest number down there. And I've got these other denominators where I want to see if I can make the smaller ones like the larger ones. So what would I multiply 2n by to make it 4n? I want to make these match. Well, 2 times 2 is going to give me the 4 that I need. And now both of these denominators now become 4n. This other denominator doesn't have anything but n, so I would just have to multiply it by 4. Just remember to do the same thing to the top of your fraction that you do to the bottom. So if I multiply the bottom of this fraction by 4, I multiply the top of it by 4. As long as we're doing the same thing to both the top and the bottom of those fractions, there we're good. Okay, so multiplying the top of this fraction by 4, I'm going to have to distribute because there's two terms here. Okay, so that's going to give me 4n plus 12. This one over here was not multiplied by anything, so it's just going to be 3n minus 1. I'll just bring that down. But I've got 2 times 1 over here, and that's just going to give me positive 2. So I'm changing all of these denominators. Now they would all match. This one would be 4n, this one would be 4n, this one would be 4n. Once the denominators match, you can pretty much just ignore them and treat the numerators like an equation. Okay, where you're doing just like we did in Algebra 1, where you're just following the order of operation in reverse. But I always want to look to see, is there anything I can distribute? Are there any like terms on the same side and all that stuff? So here I can add 12 and 2. Those are on the same side of the equal sign, same side of the equation. 12 and 2 gives me 14. And on this other side, I still have 3n minus 1. Okay, so I want to get my variable to one side. Once you've combined all your like terms, see if there's anything you can do to get this variable to one side and keep it positive. So, I'm kind of looking at 4n and 3n. Which one should I move? Because I'm trying to get n to n by itself. Well, 3n is the smaller one, so it would actually be easier for me to just subtract 3n so I don't end up with a negative n. And that leaves me with negative 1 equals n plus 14. Okay, now I need to get rid of this positive 14. I would just subtract it. So we're just solving equations at this point, and that's going to give me n equals negative 15. When I take negative 1 and minus 14, that would be my final answer there. Alright, and this is a special case here because here when I am trying to work this out, I'm going to end up getting a quadratic. I'm going to get something squared because here I've got to make all of the denominators the same, and the only difference is this one doesn't have an n, so I'd have to multiply this by n. But when I start trying to solve this equation, I've got n squared minus 4 equals 1 times n is just n. This is not your typical equation because it has something squared. When you see that something is squared, what that's going to mean is I'm going to need to do the quadratic formula. In other words, I'm going to have to get this thing in standard form like we're used to dealing with whenever we were factoring using the AC method. I want this whole thing, I want the a term, the b term, and the c term to all be on one side of the equal sign. So what I'm going to have to do is get this in standard form. So I want this n squared term to be in the front. Alright, I can go ahead and I can combine the like terms over here. I've got 2 minus 4. That's going to give me negative 2. But you'll notice I've got an n that's on the wrong side of the equation. I need to move this by subtracting it to get it to the other side. And when you subtract n, there is no other n over here that I can subtract it from, so it's just going to be minus n. And there's nothing left over here. So I had to get this into standard form before I could start solving this. So I'm not going to solve this like just solving for n or just solving for x. I've got to factor now and solve. And I could use the quadratic formula, but this is something that's going to give me a solution where I can use the AC method. Factors of negative 2 that add to my b term, which in this case, if there's not a number there, put a 1 in front, is negative 1. So I'll be looking for those two factors. Factors of negative 2, which the only factors of 2 are 2 and 1. I just need to make the bigger one negative. So those would be the factors that I start with. I've got n minus 2 and n plus 1. But remember, when we're factoring and solving, we're going to be taking both of those factors and setting them equal to 0. So I'm going to have n minus 2, set it equal to 0. And I'm going to have n plus 1, set that equal to 0. And then I'm just going to solve by, getting the negative 2 to the other side. So one of my solutions is positive 2 because I end up getting n equals 2. The other one, I have to subtract 1 from both sides. That's going to give me n equals negative 1. So those are my two solutions. So if you're ever trying to solve one of these and you see a squared term, get it into standard form so that it's in this correct order where your squared term is in the front. Remember, that's always going to be our a term. The b term always has the variable beside it, and the c term is just your constant, the number that's just by itself. So get it in standard form, then you would just factor and solve using the AC method.